Welcome once again to my channel. Yeah, this is Jellyverse, and I'm coming to take you through some of the thermodynamic questions. This is actually a past question, but I would like to discuss it with, you guys. The first question was state the law of thermodynamics, the third law of thermodynamics. Third law of thermodynamics deals with entropy, and it states that the entropy of a perfect solid is 0 at 0 Kelvin or negative 273 degrees Celsius. When you are talking about entropy, what comes into your mind? Entropy is just about randomness of molecules or atoms. So if entropy is 0, then it means that there is no randomness. All the molecules or atoms that are inside the perfect solid are stable, they are immobile. There is no randomness, there is no movement. That is what we mean by the third law of thermodynamics, or that is all what third law of thermodynamics explains. Now let's try and move to the second question. The second question is enthalpy an extensive or intensive property? Enthalpy, is it an extensive or intensive property? Justify a reason. When a property is extensive, it depends on the amount or quantity of matter present. And when it is intensive, it's the other way around. It doesn't depend on the amount or quantity of matter present. Enthalpy here is an extensive property. This is because it depends on the amount of what? Substance or the quantity of matter that is present. For instance, mole, gram, it depends on all those stuffs. If you're having 2 moles of something, the enthalpy will be doubled. The same way we're having 0.5 of that 0.5 mole of the substance, its enthalpy, whether it's enthalpy of combustion or enthalpy of formation, it will be half of it. Let's talk about question C. This is question C. As you can see, H2O matching you into H2O gas. We're having H2O liquid matching into H2O gas. What is coming to mind is that initially they say that water formed in respiration reaction evaporates. Water that is formed in a respiration reaction, it evaporates, and that is a fact. Now this is the reaction. This is what happens. Is this process an endothermic or exothermic process? Justify your choice. Justify your solution. Justify your reason. The energy here is actually endothermic. Why is it endothermic? We are having liquid going into gas. Or what it should tell you that energy is needed to break the bonds that exist between the water molecules. If the bonds that exist between the water molecules at the liquid stage is not broken, you can't get them in the gaseous stage. So you have to be broken, and if supposed to be broken, energy must be taken from the surrounding. And when energy is taken from the surrounding, instead of it releasing, we call it endothermic. So this is how simple the question is. Let's try and move to question 2. In question 2, that's where I'll be writing, so kindly pay attention. In question 2, they said a student needs 30,000 kilojoules. So 30,000 kilojoules of energy per day. And they said calculate the number of moles of glucose that would provide this daily energy requirement. Number of glucose that will provide this energy requirement. Now, they've given you a reaction. This is the reaction. The reaction is 2C6H12O6 solid plus 12O2 gas, leading you into 12 moles of carbon dioxide and 12 moles of H2O liquid. H2O liquid. Now they give you the enthalpy of the reaction. The enthalpy of the reaction here is negative 5,000 or negative 5,000 kilojoule per mole. So this is the enthalpy of the reaction. As I said earlier, enthalpy is what? An extensive property. It will depend on the amount of substance. So what I want you to note here is you are seeing 2 moles here, 2 moles of glucose. It's going to affect its enthalpy. If you are seeing that this one is, if 1 mole of glucose should undergo this reaction, you are going to get what? Negative 5,000. Now that we are having 2 moles of it, then this means that the enthalpy of this reaction will be doubled, like I said earlier. So the enthalpy, the main enthalpy of this reaction will be negative 10,000 kilojoules per mole. Now, let's use the easiest and common way of doing or solving this solution. They are saying the student needs 30,000 of that energy per day, and before you can get that energy, this is the reactions it was supposed to go through. So they've given you the enthalpy of the reaction. Now you find out that the enthalpy of this reaction is negative 10,000, and they are saying that the student needs 30,000 per day. So how many moles? So if 5,000 kilojoules per mole, if 5,000 kilojoules per mole is giving you 1, so it's giving you 1 mole of the glucose, then automatically what 30,000 give you? So our 30,000 kilojoules per mole will give us 30,000 divided by our 5,000 times, look at the reaction. Our reaction here, we are dealing with 2 moles of it, so times 2 mole. Then we will move on, times 2 mole. So now, per our calculation, 30 divided by 5 will give you 6. 6 times 2 will give you 12. So it requires 12 moles of glucose, which is the C6H12O6, as you can see. So this should be your final solution. Yes. Now let's move to question 3 or question 2b. So question 2b, they require you of a specific answer. They've given you a complete combustion reaction of propane. You all know propane. Propane is C3H8. Propane is a gas, so plus 5O2, which is also a gas, matching you into 4 moles of H2O plus 3 moles of carbon dioxide. Now this is the enthalpy of the reaction. Enthalpy of the reaction is negative 2056 kilojoules, negative 2056 kilojoules. They've given you the bond energies. So I've already shown it to you earlier. So they've given you the bond energies. Now the bond energy between oxygen double bonding with oxygen is 499. They are all expressed in kilojoules per mole. The bond that exists between carbon and carbon, 348. The bond between carbon and hydrogen, 413. And the bond that exists between oxygen and hydrogen, 460. So now that we are coming to calculate, they said calculate the average bond energy of carbon double bonding with oxygen. So automatically they didn't give you this particular one. What do you have to do? You have to do something about it. They've given you the enthalpy. You know that there is a formula that we use to find for the enthalpy of reaction or enthalpy of combustion. You know that our enthalpy of combustion here, enthalpy of combustion will give you the bonds that are broken minus the bonds that are formed. So summation of the bonds that are broken minus the summation of the bonds that are formed. So it's the same thing as reactants minus products. Yes. This one will be your reactants and this one will be your products. So we will take, if you look at propane, let me try and expand this. This is propane. Let me try and represent the hydrogens with dots for it to be simple. How many carbon and hydrogen bonds exist between propane or exist in propane? We are having 1, 2, 3, 4, 5, 6, 7, 8. As you can see, we are having 8 carbon hydrogen bonds. So 8 of them, 8 carbon hydrogen bond plus how many bonds exist between carbon and carbon? We are having 2 of them. Look at it very well. We are having 2, 1 and 2. So 2 of the carbon and carbon. Now let's move to the reactant side. Reactant side, how many bonds? This is the structure of H2O. Let me draw it in a linear form, though we know that H2O is not in a linear form. Let me draw it in a linear form. We are having oxygen, hydrogen. This is water. So if you have it, so how many oxygen and hydrogen bonds exist here? We are having 2 in 1 molecule. Per 1 molecule of water, we are having 2 hydrogen bonds. So if you're having 8 of them, if 1 is to 2, then 4 is to what? 8. So we are having 8 of the hydrogen and oxygen bond, as you can see. Then plus, this is where we come to pass. Now, this is the structure of carbon dioxide. This is the structure of carbon dioxide. This means that we are having 2 double bonds. A double bond between carbon and oxygen. There are 2. So if you are having 3 of them, if 1 molecule of carbon dioxide is to 2 oxygen and carbon double bond, then what will 3 give us? 3 will give us 6. So 6 carbon oxygen bond, as you can see. Now this is what we don't know, so you make it an X. So 6x. Very easy. So we know our enthalpy of reaction or enthalpy of combustion. They've given it to us as negative. We know that combustion is a negative or an exothermic reaction. So negative 2056 kilojoules. This time I'm not going to indicate the kilojoules. We actually need the value before we indicate it. Now, this is where everything begins. When you look at this one very well, there's oxygen here too. We are having 5 of them. Looking at oxygen forms, this is the structure of oxygen gas. So if you're having 5 of them, then automatically we are having what? 5 oxygen double bonding oxygen. So you'll be having 8 times the C and the H. You know our C and H is given as 413. So C and H 413 plus, here we come, what do we have here? We are having 5 of the oxygen double bonding oxygen, and we know the value is what? 499. Then plus our carbon and carbon, we are having 2 of them. We know the value to be 348. Quickly, then minus. The minus will entail everything here. On the product side, we are having 8 of the hydrogen and oxygen bonds. So 8 times 460 plus the carbon dioxide side. That one we don't know, so 6x. Very simple, as you can all see. So now we are having our negative 2056, giving you the whole of this. The whole of this will give you 6495. So 6495 minus this one will actually give you negative 3680. So negative 3680 minus our 6x because of this negative sign, so minus 6x. From here we move on, we do our simple arithmetic. We realize that we are going to get negative, this side of the equation will give you negative 2815. So negative 2056 minus everything here will give us a positive number, which is 2815. But because you are bringing it to the other side, you are going to get negative. So 2815 giving us negative 6x, as you can see here. Now, after doing our simple calculation, you are going to realize that negative 6x will give us a positive number, which is 4871. So positive 4871. Now we are looking for x. X is what we are looking for. So x will be equal to negative, because you divide both sides by negative first before you divide it by the 6. So 4871 divided by 6. Now this value that you are going to get will give us the average bond enthalpy that exists, or the amount of energy required, the average amount of energy required to break the bond, or required to bring the double bond between oxygen and O. So this will give us a positive number. Always you should get a positive number. If you don't get a positive number, please, you are doomed. So 83 kilojoules per mole, as you can see. Very interesting. So this is our question. All right, so yeah, let me show you something here. Like I was saying that you are supposed to get a negative value. After doing your calculation, you are going to realize that this one will give you a negative value. As you can see, this one will give you a negative value. So from here, our negative and negative here will give you positive. So you are going to get positive 811.83. As you can see, I mean, with your normal calculations, if you take your calculator and you follow along, you are going to realize that you are going to get positive 811.83. Now let's try and move to question 3. Question 3, this is where the question said 3 moles of hydrogen gas is compressed reversibly and isothermally. If something is compressed reversibly and isothermally, there is a condition that you are supposed to follow. From 7 liters to 4 liters, what do you think is happening? Is it the gas that did the work, or is the system that the surrounding that did the work on the system? Of course, it is the surrounding that did the work on the system, because this time around the gas didn't expand, it compressed. What compressed it? A force from what? An external force from the surrounding. So your work here will be positive. Now they are saying that at the same time, an energy of 4.5 kilojoules or 4,500 joules of heat was released. If they say something is released into the surrounding, what comes into your mind? Exothermic. So automatically the value that they've given it to you as 4.5 is supposed to be negative 4,500, not positive. Now they say calculate the change in internal energy of the gas. This is the formula for change in internal energy. You have your enthalpy. Your enthalpy is your negative 4500 joules. How do you find for work? Like I said earlier, there's a condition that you need to apply, because this time around they said that the work is what? Reversibly and isothermally. Isothermal means our temperature is constant. So if our temperature is constant, ln of 0 will give you, or ln of 1 will give you 0. So now our work done, let's try and find our work done. Our work done can be giving us our N R T, then ln of change in volume, because this time we are dealing with change in volume, so V2 minus V1. Now all what you are supposed to note is that at the end of the day, if you don't bring your negative sign, you are going to get it wrong. This is the formula for finding our work. They've given you mole. They said 3 moles, so 3 moles of energy. So negative, then automatically our 3. What's the value of R? R is actually a constant, and automatically it will be given as 8.314. So 8.314, as you can see. Then times your change in temperature. Now our change in temperature is given as negative 25 degrees Celsius. Negative 25 degrees Celsius, if you are converting it into Kelvin, what do you think it will happen? If it is positive 25 degrees Celsius, we add it, right? So now that it is negative, subtract it from 273, and now our value that we are going to get will be 248. So now this 248 will be multiplying our ln. Now ln of what was the initial volume? Our initial volume was 7, and now our final volume is 4. So with our simple calculation, what I've done here, with our simple calculation, we are supposed to get a value. So using your calculator, you can confirm it that your value you are going to get to be negative 34615 joules. As you can see, joules. Now how do we do? We said that our change in, what you're supposed to find is our change in U. Change in U is given by our enthalpy. Our enthalpy is negative 4500 kilojoules per mole. Kilojoules per mole. Now, This is work. All what we know about work is we are supposed to get it to be negatives. So minus, bracket open, another minus again. So we are having our minus here, negative, what was our work? 3, 4, 6, 1.5. I know this will be confusing, but per our formula, I'll be using the other way around, and we are going to get the same answer. So negative 1038.43, and this will be our original answer, kilojoules per mole, or kilojoules. So automatically this one will be kilojoules. From the question, it is kilojoules. Now let's try and use the other way around. This is our formula. This one is already negative, so using the same approach, negative 4500. Now if you read the question well, if you don't understand the question vividly, then you have to use this method. But if you read the question where you understand that your work is positive, then automatically our work is positive. Now there's no need for us to bring negative here again. So 3461.5, negative, and this time around we just introduce a positive sign. It will still give us the same answer, negative 1038.43 kilojoules, as we can all see. Now let's try and move to the next question. Very interesting. They said calculate the heat of formation of solid potassium hydroxide from the following reactions. They've given me the reaction. This is the reaction. Now these are your energies. I don't want to waste time here, so let me just show you how we are going to go by this answer. Because we need positive solid hydroxide, because we need this one, we need this positive potassium hydroxide. We are going to reverse this one. We will reverse this. So if we are reversing this, it's going to give us a negative value because the original value was positive. We will maintain this one, giving us the same 283. We will also, now we are going to take 1 and divide it by 2. What are you going to take and divide it by 2? We are going to take our first one and divide it by 2. This, we are going to take it and divide it by 2. So now let's write our reactions again. We have our KOH aqueous matching us onto KOH solid. Now we are having our K plus. Now I'm coming to write this reaction, K plus H2O. So H2O gas also giving me KOH aqueous, as you can all see. Then my last one, which is H2 plus half O2, giving me H2O. Now let's try and do something simple here. At the end of the day, we are supposed to get a reaction which is giving us a product which is solid KOH, which is a solid. So now this is the only thing that will actually give us a reaction which is given as solid. Now we are seeing that heat of formation, so this is that they must be formed from their elemental states. Here they didn't say standard, they said heat of formation. So right now this and this will cancel out. This one, water and water will also cancel out. So now let's try and write our remaining reaction and see what goes into it. We are having K plus H2 plus half of oxygen, giving us KOH solid. As you can see, very simple. Now the thing is that reversed. If you reverse something and it is positive, it will become negative. If you divide something by 2, like I said earlier, enthalpy is an extensive property. So if you divide something by 2, you are also going to divide the enthalpy by 2. So from there, we just calculate our total enthalpy. Calculating our total enthalpy, this one will be negative, this one will be half of it, and this one will be maintained. Half of this one will actually give us negative 184.85. So negative 184.85 plus negative 283.71 plus negative 3. Sorry, now I come to take this one. So negative 893.3. Now per our normal calculation, you know that you have to use calculator to calculate it. So we have to get negative 1361.86 joules, or 1.36186 kilojoules. This should be your answer. Now let's move to question 4. So let's continue from question 4. Question 4, the question was the standard heat of formation of hexane, carbon dioxide, and water. These are the values that have been given, and they've given the mass of the hexane to be 260 grams. Now what are we supposed to do? They said we should calculate for the amount of heat that was evolved by burning these 260 grams of hexane. So let's continue. Before we do something, we need to get a valid reaction or a valid equation for the reaction. If you are seeing hexane, you are seeing water, you are seeing carbon dioxide, what should come into your mind is when you burn a hydrocarbon, you automatically get water and carbon dioxide. So let's write the valid equation. Let's write the valid equation for this reaction. So we are having our hexane. We know that our hexane can exist in the gas, but usually liquid. So CH614 gas plus oxygen. We don't know the amount of oxygen. We don't know the amount yet, giving us CO2, also gas, then plus H2O, also gas. Balancing the equation, we'll be having 7 moles of water here, we'll be having 6 moles of carbon dioxide, and what we should be here, balancing the mass, we have 19 on 2. So this is the balance equation. Now what you're supposed to do is, because you have been given the mass, like I said earlier, they said calculate the amount of heat evolved. In other words, I'm trying to tell you that you should calculate for the enthalpy. You know that enthalpy is an extensive property, depends on the mass or depends on the amount of substance present. So let's try and calculate for the moles of hexane. You know our mass already. Our mass is 260 grams. How do you calculate for molar mass? The molar mass is just the summation of their atomic masses. So we are having 6 of the carbons and 40 of the hydrogen. At the end of the day, you are going to get 86. So 86.0 grams per mole. And the mole you should get after your calculation should be 3.018. mole. This should be the amount of mole. Now let's try and delve into it. Using this equation, we can use our formula. Enthalpy of combustion is the same thing as enthalpy of change for the product side minus enthalpy for the reactant side. Now we know our enthalpy of combustion, so let's try and calculate for the enthalpy of combustion. The product side, we're having carbon, so 6 of the carbon dioxide, so 6 times 300 and okay, so let me write it for it to be simple. Carbon dioxide plus 7 of the change in enthalpy for H2O, or minus the reactant side. Now I'll not be writing the change in enthalpy for the oxygen, because oxygen is in the standard state, and we know that if something is in the standard state, it is 0. Its enthalpy is 0. So we are having only for the formation of hexane. Very quick. Let's try and write it for purposes. Let's try, because though we know that this one is actually 0. Now let's try and move straight into it. Now we are having 6 of the carbon dioxide. What is the value for the 6 of the carbon dioxide? 394.8 plus 7 of the negative 241.6 minus, now another minus again, so automatically this should give a positive 76.2. After your normal calculation or using the calculator, you should get a value, and this value should give you 3983.8 kilojoules per mole. Now they say you should calculate for the amount of heat evolved. If you are calculating for the amount of heat evolved, what you are supposed to note here, like I said earlier, we are calculating for the enthalpy still, so amount of heat evolved should give you your enthalpy of your combustion divided by the number of moles, so the number of moles of the hexane. So this should give us, no, it shouldn't be divided, it should be multiplying, because we are no more finding for the moles again, so it should be multiplying. And if it is multiplying, let's say -1. So right now, if it's -1 and you bring it on top, it's actually going to be enthalpy of combustion times number of moles of the benzene. The same thing. Now what we are supposed to do is multiply the number of moles. I mean, my space is very small, so I'll not be doing the calculation anymore. Just multiply the number of moles, which is the 3.018, times your enthalpy of combustion, which is the 3983.8. After that, you are going to get a value. This should be your final answer, 1218.89. This should be your right answer. I mean, kilojoules per mole. Kilojoules per mole. And this should be your right answer for question 4. Now let's move to question 4b. We are talking about question 4b. Question 4b, they said calculate let me use a space let me use a line to separate it so that you see it very well. So this is question 4. Question 4, they said calculate your change in internal energy and change in enthalpy. What have they given you here? They said I'll calculate the change in internal energy and change in enthalpy on heating 84 grams of water from 25 degrees to 100 degrees. So automatically your change in temperature should give you 75 degrees Celsius, which it shouldn't be something difficult. Now they've given you the heat capacity for constant volume and heat capacity for constant pressure. What we are supposed to do is, how do we find for these two? We know that there's a relation, change in internal energy divided by the mole should give you your CV times your change in temperature. Now you can make change in internal energy the subject. So our change in internal energy will be equal to N times CV times change in temperature. How do we calculate for the mole? Calculate for the mole using mass over molar mass. What's our mass? Our mass is 84.0 grams. What's the molar mass of water? 16 plus 2, so it's 18.0 grams per mole. So automatically you should get a specific number for your moles. And what will be that value? Let's try and use the calculator to calculate it. Six point 4.67, so 4.67 moles. Now let's try and move it to our answer straight away. So we know our mole is 4.67 times our CV is 9.0, then our change in temperature 75. So the value that you should get here should be 675. So our value 675. This one time is to give it 675. So automatically you should get 3152.25 joules. Now let's try and calculate for our last one, which is the change in enthalpy. The change in enthalpy deals with constant pressure, and they've given us our CP. CP is 13.0 joules per Kelvin dot mole. So change in the same thing divided by the mole is equal to, this time it will not be CV, it will be CP times change in temperature. So if you are making change in this one, if you are making change in enthalpy the subject, then automatically it will be the mole times the CP times your change in temperature. Now how do we calculate for it? We know our mole already. The mole still remains the same because it's the same reaction. We know our CP, so mole 4.67 times our CP 13.0, then multiplying our change in temperature, which is 75. So 75 degrees Celsius. Now our value that we will get should give us the right answer, or should give us the final answer, which is 4553.25 Kelvin. Times 25 joules. If it is expressed in kilojoules, to make sure that you present your answer in kilojoules, like how you are seeing. So depending on the question, whether they give it to you in Kelvin or joules, so this time they give it to you in joules, so this will be the right answer. If you want to convert it into kilojoules, it's just 3.152 times kilojoules or something. This one will be 4.5 kilojoules or 4.6 kilojoules. Let's try and move to our last and final question. So what you're supposed to know, this type of question, don't mean they give it to you. What you're supposed to know is just recall your formula. Let me make it, recall your formula change in enthalpy is equal to N times Cp times change in temperature. If you are dealing with change in internal energy, we are having N times Cv times P, no, change in temperature, the same thing. So these are the two things that you should keep in mind for the formulas. Now let's try and move to question 5. Question 5, they are talking about benzene. So they've given you the mass of benzene to be 10 grams of benzene was burnt completely, combustion reaction, was burnt completely in the coffee cup calorimeter. The temperature of the calorimeter rises from 23 degrees Celsius to 29 degrees Celsius. Automatically, you're changing your differences in temperature will give you 6 degrees Celsius. Then our heat, the heat of capacity or the heat capacity of the calorimeter measured in a separate experiment is, so they've given you the specific, they've given you the heat capacity of the calorimeter, which is 4.9 kilojoules per degree Celsius, which is giving us this. Now they said calculate your change in internal energy and change in enthalpy. Now what you are supposed to note here is very simple. I brought my marker here in order to make this thing very simple for you. Yes. So this is the formula. I'm highlighting it so that please you remember it. So this should be your formulas that you should keep in mind for that particular question. Now let's try and move into it. What are you supposed to know here? They've given us mass of benzene. First of all, they said benzene. They didn't give you the chemical formula for benzene. But you all know that benzene is C6H6. So from there, we continue with our journey. So our mass is 10 grams. What's the molar? So before you can calculate for the molar mass, you need to know the chemical formula, which is a C6H6. So automatically, our molar mass for benzene should be calculated as such. How do we calculate for the molar mass of benzene? Molar mass of benzene can be calculated 6 times 12, because one carbon is having 12 grams per mole. So 6 times 12, 6 times 12 gives you 72. Then we are having 6 of the hydrogen, so plus 6, which will give you 78. So 78 grams per mole. Now we know our, so let's try and find the number of moles of benzene. Number of moles of benzene can be calculated as the mass, which was the 10 grams, and our 78 grams per mole, which automatically the mole that we are supposed to get should be 0.128 moles. Now let's try and look at something very simple here. Per the question. Let me zoom it out so that it become very simple. Now per the question, we are talking about combustion. We are talking about combustion. So what you are supposed to know is there will be a heat loss or there will be a heat gain. Now the heat loss by the calorimeter will be equal to the heat gain by the reaction. So there will be something like this. Heat by the change in enthalpy of the calorimeter is the negative of the change in enthalpy of the reaction. As simple as such. So if you know this, then automatically we are good to go. They've already given us our Cp, Cp is actually trying to tell us that it occurs at constant pressure. Then we know our mass, we know our mole, we know our change in temperature. So let's try and find the reaction. Let's try and find our change in enthalpy for the reaction. So our change in enthalpy for the reaction, we know that combustion is an exothermic reaction. So let's try and put our negative there. Then also our Cp. The formula is Cp times change in temperature. So automatically we'll be having negative. We know our Cp to be 4.9. So 4.9 times our change in temperature, which is 6 degrees Celsius. So automatically we are going to get 29.4 kilojoules. This should be our right answer. 29.4 kilojoules. Now, what are we supposed to do next? Let's find our change in internal energy. Change in internal energy should give you. Now, I want you to know something here. Even if you are calculating for your change in internal energy and you don't know the formula, just try and record the unit. The unit for change in internal energy is kilojoules per mole. So if you are having your kilojoules already, then what you have to do, the formula for change in internal energy is kilojoule per mole. So the per mole that is actually there is actually 23 that you have to divide by the number of moles. So 29.4 kilojoules divided by your number of moles. We've already calculated for the number of moles, which is 0.128 moles. So automatically, what will be our answer? Our answer will be negative 2. Remember to put the negative there because it's an exothermic reaction. So negative 229.32 kilojoules per mole. That's how come we find our change in enthalpy. Very simple. Now let's try and delve into something very new here. Because it was combustion reaction and you need to find our enthalpy, we need to get a valid chemical equation or the reaction equation. Now we are burning benzene C6H6, which is liquid, plus oxygen. We all know that combustion occurs in oxygen. Here they say complete combustion. It shouldn't be partial. For that matter, it's going to give you, or it will yield you, carbon dioxide and water. So carbon dioxide plus H2O, which is also gas. The H2O appears in the form of gas. Now, to balance the equation, what we are supposed to do? After balancing the equation, you are going to realize that you're going to get 12 here. You are going to get 6 of the H2O, and here you are going to get 15. Please try and balance it. If you don't know how to balance the reaction, try and balance it, you'll get it. And here will be 2 moles. After balancing the equation, you should know that there should not be fraction. So if there's a fraction, this one will be 15 over 2. 15 on 2, you have to divide through by 2 and get your answer. This one would have been 6, this one would have been 3. This one would have been 15 on 2. You know, we don't need the fraction, so just multiply through by 2. You clear off the fraction. Multiplying by 2, you are going to get 2 moles of benzene. Now, hope you understand. So let me try. Yes. So now that we are having our equation, our valid equation, what do we know about finding what is the relationship between enthalpy and change in U or change in E? Remember, change in U is the same thing as change in internal energy. The relationship between this is we are having change in H to be equal to change in U plus N, change in N subscript G. then RT. You remember the formula? Change in N means the change in number of moles of the gases in the equation. Let me try and write the equation here again. We are having 2 moles of the benzene plus 15 moles of the oxygen, giving you 12 CO2, then 6 H2O. This one is a gas, this one is also a gas. Now, what's the change in what's the difference in the moles of the gas? Product minus reactants. You are having 12 moles of carbon dioxide and 6 moles of, so automatically this one will give you 18. So you're having 18 on the product side. This one is liquid, this one is not gas, so automatically minus 15. Only the oxygen that will be left. We are having positive 3. Kindly note positive 3. If it is negative, we should indicate it's negative 3. So negative or positive, so positive 3. Now let's try and move on into our equation. Automatically they will give you R. R is a constant, which is 8.314. 8.314. Forget about the unit words. Automatically what we are looking for is the enthalpy change. And what's our change in temperature? Change in temperature also remains the same. Our change in temperature will be, what was our change in temperature? Our change in temperature was something like, let me look at the question again. Change in temperature was 29. So we have to convert it into Kelvin. After finding your temperature, you have to convert it into Kelvin. If you are converting it into Kelvin, so it was from 23 to 29. So your 29 degrees Celsius, this is what you are going to use in the conversion. Please kindly take note. This is the final temperature, so this is what you are going to use in the conversion. If you want to convert this one into Kelvin, just add 273. 273 will give you, plus 273 will give you 302 Kelvin. Understand? Now let's try and find our change in enthalpy. We know our U already. Our U is negative 299.32. Now, what do we have for this side? You know our change in moles, which is 3 times 8.314. Then our change in temperature, which is 302. Very simple. 302. Now, doing all your calculation, you will get your change in enthalpy to be 7236.9. Then you will bring your units, whether it is kilojoules or not kilojoules, but this time it is kilojoules per mole, so kilojoules per mole. So this will be our final answer. Hope you are all good. So this is the final question, and automatically this one is also the final answer. Don't forget to subscribe and like. If you want to comment, you can also comment on it. Thank you for watching my videos. I hope this one finds you a better understanding. I wish you the best of luck.